All right, recording started. For y'all that listen to my first highlights, I'm gonna do them again just right quick. I've also forgot to flip slides. So back on page one, just going through my highlights. Page one, second paragraph, first sentence. There are three types of fish tape: steel, nylon, and fiberglass. You want to have that first sentence highlighted. And then moving on to page two. Page two in 110, planning the installation. I've got the third paragraph, first sentence highlighted. Whenever possible, the conductor should be pulled directly from the shipping reels without pre-handling them. And then page three, second to last sentence. I think they missed a period. Second to last sentence on page three is highlighted. If the feeder raceways have been installed relatively early during the building construction, waiting to order the cables until the raceways can be measured may not delay the final completion and installation. So that, again, that's just because wire right now is pretty readily available. There's not back order on, unless you're doing like a super high tech, some sort of instrumentation cable, like especially power wires are pretty readily available, and you can get the, like, ordering those isn't a big deal. Flipping over to page 4 and 5, I don't have any highlights on 4 and 5, but we just talked about the basic steps of wiring pole operation. Then you have your measuring tape. In that tan box on page 5, like that's a rope that you can pull bigger cable through. You actually see, I don't know how many of y'all drive through like Chalmette and Araby, but if like the back road that I take to get home, Araby and Chalmette are currently getting fiber. For fiber internet and stuff, and they've got the orange like conduit lines, and then they don't have the fiber in yet, but you can see that measuring tape is sticking out of all their conduits. They're getting ready to pull their fiber lines in with that stuff, and it's a lot. The regular nylon stuff you use, this stuff is a lot stronger than that for pulling much bigger cables. Flipping over to page 6. So page 6, we're still talking about pulling setup and locations. The first full sentence on page 6, that last sentence of that paragraph is highlighted. When available, a forklift is ideal for lifting and transporting cable reels. I wrote a little line to the top for a little note. A forklift is ideal for lifting very large reels. So if you have big reels, like you can see on page 7, like in the yes column, like a forklift for big reels like that is what they're used for. Next, immediate next sentence on page 6 is highlighted. However, for very large reels, a crane or similar hoisting apparatus is usually necessary for lifting the reels onto the reel jacks, supported by jack stands to acquire the necessary height. Preparing raceways. Preparing raceways, on the right-hand side of the page, that first full paragraph on the right-hand side, first sentence is highlighted. A test pull will detect any hidden obstructions in the conduit before the pull. The sentence after it's not highlighted, but it's useful. The first sentence is highlighted, and then out to the side I wrote that's the preferred method. Preferred method is using a test pull, and what that means is that next sentence says no-go mandrels, no-go steel and aluminum mandrels are available for pulling through runs of conduit before the cable installation. And what that means is they have figure 9. So if you just flip the page to 8, you can see, I guess I haven't been going. Let's see. Shoot. Nope. It doesn't matter, but if you can see this on the board, like that picture right there, you can see the mandrel. So if especially like we talked about those ducts that run underground, those can get concrete or water or something like that in them. So if you're pulling a cable that's worth thousands and thousands of dollars, you don't want to pull that joker through a conduit that has concrete in it, that some concrete guy just ended up slushing some down in the concrete pipe. So they'll pull a go, no go mandrel to make sure that everything is good to go. So you can see like the backhoe tooth mark, concrete, flat and bend, like they're making sure that that pipe is good to go before they're pulling some major stuff through there. If you back on page 6, that immediate next sentence about mandrels is highlighted. Mandrels should be approximately 80% of the conduit size, or twice the 40% fill factor. So you're technically, like NEC says, you can only fill a pipe with conductors 40%. So 80% is making sure that you can get that pull done. On page 7, I have the no side highlighted with the first sentence. On the flat side of the spool, on the cables, like you're not supposed to store them like that. You're supposed to store them sitting up. I think those big reels like that can deteriorate over time, but you're not supposed to store them like that. Now we move on to page 8 and 9. Installing a pull line 140. So you can also see they have different types of, like they got the loop spreader swab, the conduit brush, flexible mandrel, different ways of cleaning stuff out. Typical reel stand, like I said, never really had anything that fancy. Sometimes we just took a piece of conduit and set it between 2 chairs, and that's what we pulled off of. But I can see where having something like that would be, man, especially if you had like raising jacks and stuff like that. It would be nice to have something like that if it's available to you. 140, installing a pull line. For the sentence that's right above the bullet points is highlighted. The most common wire pulling ropes on the market include the following, and I have the nylon one highlighted. Most common wire pulling ropes on the market include the following, and I have the nylon one highlighted. On the right-hand side of page 9, I've got the sentence that's right before the blue fish line sentence highlighted. The foam piston is sized to the conduit and has a loop on both ends. So this is talking about, a lot of times that thing's called a mouse, I'm pretty sure. So what they're talking about, surely they have a picture of this. If you flip over to page 10, you'll see this picture right here. So you can actually have, these actually work pretty well. You can see those foam pistons that are connected to a little string, and you can actually set up like a shop vac on one side and pull those foam pistons through. I never had like the fish tape system like that. We had nylon cord that we tied. We wadded up a couple pieces of paper and taped the nylon cord to it. We were able to like suck the paper through the pipe and get the cord. So whenever it works very easy for pulling that stuff, and then you can pull your wire through afterwards. But yeah, I'm sure those foam plugs or whatever pull a lot better through a pipe than a wadded up piece of paper, but sometimes you just make stuff work. Preparing cable ends 150. Several highlights on page 11. First paragraph, second to last sentence has a couple highlights in it. The use of the proper type of grip or basket will facilitate the pull, but in many cases, especially on long pulls, workers prefer to use a 3 or 4-hole cable grip with set screws that secure each conductor to the pulling block. I have that cable grip underlined with an online test question. Cable grip is underlined with an online test question. That goes along with that highlight. Next paragraph, second sentence is highlighted. Note that the no lube insulation on certain types of cable requires the wires to be stripped at the basket, and the basket applied to the conductors rather than the insulation. Next paragraph, first two sentences. Most pulling blocks have a rope clevis as an integral part of the block. However, when using pulling grips or baskets in 2-inch or larger conduit, a rope clevis is normally used to facilitate connecting the pulling rope to the wire grip. Two types are currently used, the straight clevis and the swivel clevis. Top right of the page. First two sentences in the top right are highlighted. In general, the ends of conductors should first be trimmed. Cable cutters capable of cutting conductors through 1,000 kc mil save workers time over using a hacksaw. So once you get into, like we talked about, like anything over 4/0 cable is measured in kc mil. And I've seen contractors and stuff sit there and cut one of those cables with a hacksaw or bandsaw or something like that. But you can get big cable cutters. I don't think I have. They don't have a picture of them, but I think you've seen them. They're like $250, $300 for a nice cable cutter. But whereas sitting there messing with a hacksaw or a cable cutter, sometimes it's worth it if that's the stuff you're doing every day. Moving on to page 12, 160. Selecting cable pulling equipment. The last sentence of that paragraph on page 12 is an online test question. The other end of the rope at the cable puller is wrapped around the rotating drum capstan on the cable puller. Let's just show that. If you flip over to page 15 right quick, you can see the picture that's on the board. I don't know how well you guys can see that picture, but this is what the rope that's running through the pipe, and then it's the silver part is the capstan. And then it says you have 5 wraps. So I think, no, I'm not getting ahead of myself. I have a highlight for that. Flip back to page 12 and 13. The warning on page 12 is highlighted. Always use wire pulling lubricant that is compatible with the type of cable being pulled. Failure to do so can result in unsafe pulling forces and cable damage. Check the cable manufacturer's recommendations and always contact the lubricant manufacturer about the compatibility of lubricants with specific cables. I think I've ever done that. We just have bottles of the lubricant stuff, pour it down the pipe. Page 13, you can actually see the hex head screws for those clamps. So you can see the clevis that has that can swivel and the clevis that doesn't swivel. So this is the one where you would trim the ends of the wire, stick the wire in those 4 holes, and then clamp them down with those hex head screws to help pull it. And then it has the basket type at the bottom. Bottom of page 13, second paragraph. The first sentence is one highlight. That'll be it's part of both highlights, but the first sentence will be a practice test question, and then the next 2 sentences are part of the other highlight. Either way, first 3 sentences are highlighted. The number of wraps on the puller drum decides the amount of force applied to the pull. So the amount of wraps that go around your capstan, which the picture on the board, or the picture on page 15, decides the amount of force to be applied. For example, the operator needs to apply only 10 pounds of force to the pulling rope in all cases. With this amount of force applied, by the operator, and with one wrap around the rotating drum, 21 pounds of pulling force will be applied to the pulling rope. 2 wraps is 48 pounds, 3 wraps is 106 pounds, etc. So the number of wraps that you do around that capstan, each time you do it, your weight goes up, or your pulling force goes up significantly. So, and it doesn't, you don't want to just wrap it 5 times and pull 12 gauge wire, because you'll rip it apart. You want to have the right amount of pulling force. Page 14 shows some pretty cool, those are called, on there they call them glow in the dark fish poles. Like most of the time, people in the industry call those glow rods. Those are helpful when you have to, when you're fishing stuff over long distances. Like you can see that guy's like above a drop ceiling pulling stuff. I've also, like whenever we did the, I worked at Harris Casino as a subcontractor, and we put in like the, I think it was for T-Mobile. We put it like there's bad reception inside the casino, so we put in cell phone antennas inside the casino, and we had to do a lot of stuff and drop ceilings. Like you can do what he's doing and like stretch that thing over. We took a tennis ball and tied a nylon string to it and threw it to each other over long distances, and then made the pull. Like there's a bunch of ways of doing this stuff, and sometimes it's just kind of what's the most practical. It doesn't have to be made specifically for pulling wire and stuff. Sometimes you just have to make stuff work. Flipping over to page 16 and 17, you're gonna have a question come out of table 1, and that's what we talked about, the number of wraps and corresponding to the amount of pulling force. So you'll have a question come out of table 1 from your module review. Pulling safety. They go through I'm on page 16, pulling safety 161. They go through bullet points that are precautions for power pulling. I've got the last bullet point right above 162 highlighted. Remind all workers that anyone can stop the pull if it seems unsafe. So like any other type of operation, anybody can stop the pull. Types of cable pullers, 162. You can see them over on page 17, but I've got the third sentence in 162 highlighted. The self-contained hand crank wire puller in figure 17A is designed to pull up to 1,500 pounds with only 30 pounds of handle force, which is nice. Just being honest, I've never used a cable puller ever. Like it's always been by hand, and it would have been nice to have some type of mechanical puller, but for the electric pullers, like it was always done by contractors, and we never had a mechanical cable puller. But that's something that would be nice to have around, because sometimes if you were on the pulling end of something, you were doing some work. So yeah, just having a mechanical puller that has the ability to pull 1,500 pounds would be nice. Flipping over to page 18. Cable pulling instruments, page 18, 163. So you have a bunch of cable pulling instruments, cable length meter. I don't have a highlight on this, but you can see at least the picture on the board. I don't know where you have that picture. Oh, you have that picture on page 20. You can actually have a cable length meter, which is super nice. I don't know how interlocks or wherever you end up working is gonna have stuff, but like in the steel mill, if we needed a certain amount of cable, we went to the warehouse, and there were times where we're like, I'm not sure if this reel has enough. Should I open up a new reel? If they would have had one of these cable length meters where you could just put the dial to what gauge wire it was, put one on one end and one on the other, and it tells you they've got 73.9 feet of cable. Like, probably would have saved them some money rather than us opening up a new reel. We could say like, oh, this is almost exactly right. We take the one that's almost empty. I just want you guys to know that there's tools like that are out there. There's also, later on in electrical, we'll talk about like every or instrumentation, we'll talk about like every type of wire has a certain specification for resistance per foot, and technically you can take an ohm reading on a cable and determine length based on that, but I don't feel like that's as accurate. But back on page 18, I do have the first sentence of the dynamometer or the force gauge highlighted. This type of meter is designed to read the dynamic friction or the pulling force during a cable pull. So that just makes sure that you're not going to rip the cable apart. Like some of these cables have a certain measurement for how much force can be applied when you're pulling them. All right, that's through the first section. Like I said, I'm just gonna keep going and give y'all everything to do at the end. So I'm gonna move on to section 2. Let me see. I do that weird. Second. Oh. All right, section 2. You should know what a sheave is. We're going to talk about them for the trade terms. It's just a pulley-like device used in cable pulls in both conduit and cable trays. On page 23, I only have one highlight. It's the third to last paragraph on the page. The entire operation should be supervised from start to finish. Therefore, communications equipment must be utilized on both ends of the pull at all times. Out to the side of that, I wrote most important tool. Your most important tool during a pull is your communication systems, making sure y'all's radios have enough battery, because the last thing you want is, like I said, like if you're pulling a lot of wires at once and they're coming off of a cable reel or something. So I've got 10 wires going into a piece of pipe, and like something happens where one of them gets kinked up, you need to hit the radio and say stop the pull, so you can straighten stuff out on your end so it can go into the pipe smoothly. Because if that ends up in the pipe and you're using a power cable puller, there's a good chance you're going to rip that one conductor, and you're going to have to start all over. So it can cause big issues. So make sure that your communication systems are good to go whenever you're doing that stuff, especially whenever you can't visibly see each other or different rooms or anything like that. Flipping over to page 24, I've got 5 highlights just on page 24. The feeding end. So the feeding end is actually more important than the pulling end. The pulling end, they're just sitting there pulling, like they don't care. The feeding end, you have to make sure that the wire's going in the pipe the correct way, making sure there's no kinks, making sure you're feeding the wire into the pipe to make it easier, putting the lubricant in there for the wires. Much more important on the feeding end, at least in my opinion, than the pulling end. In 210 feeding end, second sentence is highlighted. Choose a rope that has at least 4 times, key on the 4 times, the strength of the required pulling force. That is, if the estimated pulling force is 1,200 pounds, the rope should be rated for no less than 4,000 or 4,800 pounds. Second paragraph, first sentence is highlighted. The feed-in setup should unreel the cable along its natural curvature as shown in figure 23A. So if you look, either if you can see that on the board, but the picture on the board that's at the top of page 25, you want that cable to unreel in a natural way. If you do like step B, like the 23B, you're going to cause issues, and that's going to have a lot more tension in the line pulling like that rather than the other way. That's all that's saying. Second to last paragraph on page 24, last sentence is highlighted. For pulling around bends, use the conveyor sheave assembly of the appropriate radius series, such as the one shown in 25B. So flipping over to page 25, and you can see some sheave assemblies. So that's just if you're making a corner in a cable tray or something like that, you can put those assemblies in there, and they make sure you're not pulling tight against a corner or something like that. Like the picture that's on the board. So I'm on page 26, 220. Supporting conductors. First paragraph, last sentence is highlighted on page 26. Intermediate supports must also be provided as necessary to limit supported conductor lengths to not greater than those values specified in NEC table 300.19. Last paragraph on page 26, the first sentence is an online test question. First sentence on the last paragraph of 26 is an online test question. A variety of supports are manufactured specifically for supporting cable and vertical conduit runs, and many ideas can be obtained from the manufacturer's catalogs. Vertical conduit runs are important. If you're looking at page 27, you can see they have like the picture I have on the board in figure 27. Like if you have those cables weigh a ton, and if you're running them straight up the side of a building like a few stories, that's a lot of weight that's sitting there hanging. So you got to put these wedges in there or some sort of support at every level so that your cables. Last thing you want is doing a cable pull, and one of those cables lets go and starts flying down the pipe. It's a bad day for everybody. The next highlight on page 26 is the next sentence through the end of the paragraph. Therefore, make an effort to obtain such catalogs from electrical suppliers or manufacturers' representatives. In fact, manufacturers' catalogs of electrical tools and equipment are excellent study guides for any phase of the electrical industry. Manufacturers of electrical equipment want their equipment used, and they have found that one of the best ways to accomplish this is to provide easy to understand instructions and examples of practical applications. Most manufacturers go to a great expense to provide this information, but it's usually free of charge to those working in the industry. So if you ever have questions on this stuff and you've been in the industry for a couple of years, lean on your suppliers and stuff like that. Hopefully, like we have a couple guys that should be coming in for a couple days for y'all that are going to teach different things. We haven't talked about swedge lock fittings yet. That's more of an instrumentation tubing fitting, but I have the guy, like one of the main sales guys from Swedge Lock is going to come in and do like a tubing demonstration and talk about that stuff and how to put it together, and everybody's going to get a piece of tubing and bend it at the desk and stuff like that. That guy's going to come in. Then I have a guy from Emerson that's going to come in and talk about differential pressure cells and vortex shedding flow meters and just different stuff like that. Like these people, like companies spend millions and millions and millions of dollars on this stuff, and these companies want people like you guys, the people that are learning how to use it. They want you to know how to use it, because 5 years from now, when you guys are the project managers or in charge of projects and stuff like that, and you're ordering different parts, you're going to be like, nah, I'm going to order Swedge Lock or Emerson, even though they're more expensive. I know how to use their stuff, and I have a contact for support, and I know they're going to be there whenever I need them, stuff like that. Like companies want, will spend some money just to get you to buy their stuff, but they want you to know how to use it, because if you do, you're going to use their stuff. So lean on them once you guys get into positions like that. Lean on your vendors and stuff. And even if you guys get into a supervisor role, It's always like maintenance guys always like, we used to do stuff at Goodyear called lunch and learns. So we would take an hour lunch and somebody would come in and provide, like a vendor would come in and provide lunch, and then they would talk about seals or air compressors or something like that. Like everybody likes that stuff, to get a free lunch and maybe sit there and do a little learning while they're doing that. So lean on your vendors. Page 27. Top right of 27, that first full sentence up above, the warning up there is highlighted. Consequently, braking systems should be installed on all long vertical cable pulls. So that's like the conductors supported with the wedges. You have to put some type of braking system in there. 230, pulling cable and cable trays. The first paragraph is highlighted. When long lengths of cable are to be installed in raceways or cable trays, problems are frequently encountered, particularly when the cable has to be pulled directly into the tray and changes in direction of the tray sections are involved. An entire cable pulling system has to be planned and set up so the cable can be pulled into the tray without scuffing or cutting the sheathing and insulation, and also try to avoid damaging the cable trays or the tray hangers. To accomplish a successful cable tray pull, the complete line of installation tools is available for pulling lengths of cable up to 1,000 feet or longer. Key in on this next sentence. These tools consist of mainly conveyor sheaves and cable rollers. Figure 28 shows a partial cable tray system with a sheave and roller in place. So these tools consist of mainly conveyor sheaves and rollers. Out to the side, I wrote that's for cable trays. Those sheaves and cable rollers are for cable trays. So if you're looking at page 28, or up on the board, that figure 28 on page 28 just shows your cable tray with your sheave in there. And that would be, in my experience, like that would be nice. It'd be nice to have an empty cable tray and be able to go put that in there and pull that around the corner. In my experience, as an intern or the low man on the totem pole, I'm sitting there climbing through the cable tray. There's wires already in there. I'm making sure I'm not damaging those and pulling this thing by hand. That's normally how I've done it. If you're in the commercial side and you're installing new stuff, yeah, go ahead and put those in there and use those. But I've never seen one of those. Would be nice. Page 28. First two sentences are my first highlight on 28. In general, the pull exerted on the cables pulled with a basket grip should not exceed 1,000 pounds. For heavier pulls, a pulling eye should be used. Second paragraph, everything left in the bottom, that paragraph in the bottom left is highlighted. The bending radius of the cable should not be less than the values recommended by the cable manufacturer, with a range of 4 times the diameter for rubber insulated cable with a 1-inch maximum outside diameter without lead, shield, or armor, to 5 times the diameter for interlocked cable plus or cable armor, interlocked armored cable per NEC section 32024. You can see at the bottom, you can, like they have, that's a smart puller. Never seen one of those, but you can actually hook, like, I guess they have Bluetooth or something like that. You hook it up to your phone and see how much force you're pulling. Like that's, it looks like it's powered with a little Makita battery. That's pretty cool. I don't think I've seen that before. Would be nice. Still on page 28, that second to last paragraph, first sentence is highlighted. Best results are obtained by pulling the cable in one continuous operation at a speed of 20 to 25 feet per minute. We talked about that in electrical 1. Like these are, it's better to pull in one continuous thing all the way through. When you stop, you have to overcome the friction that whole wire touching the conduit or cable tray is all at once. So you don't want to stop. Like you want to keep pulling if at all possible. Page 29, the paragraph that's right in between the notes, first sentence is highlighted. Sheaves must be supported in the opposite direction of the pull. So you can see that sheave on the board or on page 28. You can see those supports are pulling the opposite way of the pull. That's just counteracting the force of the cables. That's the end of section 2. Got one more section. Section 3. Only one trade term there, tensile strength, the pulling force required to break a rope, wire, or structural beam. This is going to talk about the limitations of cables being pulled. So last thing you want to do is rip a cable apart when you're doing a pull. First bullet point on page 31 is highlighted. So these are just important guidelines. First bullet point, while reels are in storage, either before or after the pull, the conductor ends must be sealed to prevent moisture from entering or creeping into the cable ends. The second bullet point is highlighted as well, separate highlight. The minimum ambient working temperatures for cable pulling operations depend on the cable jackets. In cold weather, cable reels should be stored in a warm area overnight so the cable jackets will be at the proper temperature for pulling the next day. Not quite the same thing, but I know when I was growing up, going on family vacations, my mom would always have us go on like a factory tour for like a learning experience, which I thought was dumb then. But now I think back and we've done like we did a couple different like car factory tours. And I remember this section where they were putting in the wiring harness. They actually had a spot where they would plug in the whole harness and push amperage through the harness to warm the whole thing up because moving the wires around after they were a little bit warm was way easier. So if you're doing a cable pull, like it matters. Like it's like if you think about it, like rubber gets a lot stiffer the colder it is. So if you warm it up, it's going to make your cable way more or way easier to pull. You just want to like obviously, I mean, it should be like putting it outside on a day like today would warm it up enough. But you don't want to leave cables outside so long that they would, a lot of stuff's not rated for UV light. So you just want to do it enough to warm them up. Top right of page 31, third bullet point up there, pull with a capstan and no faster than 40 feet per minute. Allowable tension on pulling devices 310. First paragraph of 310, last sentence. If catalog information is not available, work at 10% of the rated breaking tensile strength. If catalog information is not available, work at 10% of the rated breaking tensile strength. Next paragraph, first sentence is highlighted. The allowable tension with a basket grip must not exceed the pounds per circular mill values as shown in table 3 or 1,000 pounds, whichever is smaller. So either you have to go by the chart or you never, like the highlight we had before, with a basket grip, you never pull with more than 1,000 pounds. Allowable tension on conductors, 320. Last sentence on the page. Last sentence on page 31. Reduce the maximum pulling tension by 20% to 40% if the conductors are being pulled simultaneously because the tension is not always evenly distributed among conductors. So if you're pulling more than one, you have to reduce it by 20 to 40%. Page 32. Page 32, third paragraph is highlighted. For a straight horizontal raceway section, the pulling tension is equal to the length of the duct run multiplied. Remember, duct is like a passageway underground. Duct run multiplied by the weight of the cable and the coefficient of friction, which will vary depending on the type and amount of lubrication used. Therefore, the equation is as follows: T equals L times W times F. You're gonna have to do one of these problems. It's not tough. All you're doing is T is your total pulling tension, L is the length of the raceway, W is the weight of cable in pounds per foot, and F is the friction. Not that it matters much, but a lot of times, like just in the engineering classes I took, usually the coefficient of friction was marked with a K and not an F. But probably doesn't matter. You're gonna have a section review question come out of table 3. Just highlight table 3 for physical limitations of cable. Sidewall loading. So this is like loading the sidewalls of cable trays. The last sentence on page 32 is highlighted. Sidewall loading is reduced by increasing the radius of bends. So the bigger the radius is, the less tension you're going to have. Page 34 and 35, 330. You can see like you're like pulling around a corner, you're gonna have a lot of tension on the sidewall. You're gonna have questions from the section review and module review come out of table 5. Yeah, have that come out of table 5. And that's it. That's all I got for this chapter. I'm gonna give y'all time to do this. We'll start this back up. I'm gonna check this stuff. I'm gonna give you time to do it now, but I'm gonna check this stuff on Monday. So I'll check all this stuff because we can't test, we can't do virtual tests, but I'm gonna give you about an hour to do this stuff. So whatever you get done, get done. I gave you a practice test, right? No? All right, well, that's my bad. Do the stuff in the book. I think my meeting's over at 10. As soon as I can get back, we'll go through the next chapter, and then after that we'll be done. So we've got cable tray. Yeah, probably about 10:15. So you got about an hour to run through this stuff in the book, and then 10:15, we can jump back into this meeting, I think. If not, I'll just send out another link and we'll go with that. Everybody go with that? Anybody have any questions? All right, then, I'm gonna stop the recording. I'm just gonna leave this running, and that way we can jump back into it.